Welcome back, and let me welcome here and introduce our own Professor Jiří Raclavský with his presentation on the topic two-dimensional conception of inference.
Thank you for introducing. Dear ladies and gentlemen, I must thank the organizers, I must thank to the reviewers of my paper, and I must thank to all of you for coming to this talk. I was looking for conference in the list of conference, and I found that there is an interesting conference. I was interested what's going on and creating a sketch of a paper in my mind, and then I found that the conference is organized by my former students. So I'm happy about that. I was surprised that they are so independent that they do not ask me to work on the conference. So they are adult from the viewpoint of a teacher. Yes, it's a nice point. I feel it personally that our students are successful as in a scientific world, even in this way. Okay, one reviewer asked me to be less technical in my talk, and I realized that it's a good idea. I simplified my slides, so they are more simple than I expected from when I was writing the abstract. I put some things apart, so there's something substantial I want to say. It's on the slides, and I'm talking, of course. Well, what's my problem? Most of you have visited an introductory course to logic, so you know the basics, and you think that logic might be perhaps useful. Not all of you are logicians, I know that. And what I'm going to do with you is to change your mind, not only because of usefulness of logic, but even the reason why it is so. So the two-dimensional conception of inference is a revision of something which might be called one-dimensional conception of inference, and this is what you have received in your introductory course to logic. So, to repeat the very basics, we are studying argumentation. Many people studied argumentation from some viewpoint. Argumentation is presented to us in a form of sentences, and now there is a worry that not every assumption needed to establish the conclusion is expressed. This is an intuition I will use below, so I will offer you something more complicated than mere strings of formulas or sentences. We are in the introductory section, so to be sure what is my terminology, by an argument I mean the linguistic entity consisting of sentences, where the last sentence is called conclusion, and the other sentences are not called premises for some reason, but assumptions. What logicians do is to model such an argument by a derivation, which is a sequence, that is a numbered list of formulas. Each such formula is a step in a derivation. This is something quite familiar to you, only some terminology might be different than the terminology you know. Now, there is a distinction between one-dimensional and two-dimensional conception of inference. It's by Pavel Tichý. We will talk more about it later. So this is only to show you the very basics. What you know as derivation is called by me and formally by Tichý one-dimensional conception of inference. So it's a model of inference as a sequence of formulas where inference rules operates on formulas. These formulas are in fact most of them are mere assumptions. Now, some ideology behind two-dimensional approach is to perform inference on logical truth. So the basic idea is to go from one truth to another truth, not from assumption to another assumption. So this forces you to revise the concept of inference, where the two-dimensional concept of inference takes whole derivations as inference steps. And inferential rules operates on those derivations. It seems at the present moment that a simple world of common logic gets complicated, but it will not be so difficult as it seems at the very moment. Firstly, I will briefly recap what's one-dimensional conception of inference, and I will criticize it. I will criticize some crucial bad points of that, say, ideology of explaining inference. Then there will be two sections on two-dimensional conception, which fares better in explaining inference, and there is a conclusion and so on. In the application part, there is an ordinary language example of argumentation explained by the two-dimensional manner, and I hope that this will be the place which will convince you most. So to repeat, one-dimensional conception of inference takes formulas as inference steps. Inference rules operates on those formulas, that is on those steps. Not every step is a logical truth. It's very rare that a logical step is a logical truth. So most formulas occurring in an inference are contingent formulas, so to speak, formulas which are not true by necessity. And conclusion is supported by the assumptions. There should be assumptions in the sense that there's an implication which mimics the inferential force which goes from assumptions to the conclusion psi. Okay, let us take it for granted, and here's a simple example. On the left side you see an argument which is mimicked by a logician as a derivation. There are two assumptions, the formulas 1 and 2, and the last formula, the conjunction of the two assumptions, is obtained by the rule called conjunction introduction. There seems to be no problem. This is something we know from ordinary course of logic. Yes. Where are the problems if you take the viewpoint of a two-dimensional conception of inference? There is a problem. You started with two assumptions, and what you get in this inference is another assumption. It is not a logical truth. So, what is the usefulness of such sequence of assumptions? The last assumption is dependent on the preceding ones. It's a dependent assumption, but still it's an assumption. So, on one-dimensional conception of inference, inference is epistemologically unconvincing. You go from assumption to another assumption. There is another piece of reasoning quite familiar from 1,000 years in Europe, and not only in Europe. It's often used in philosophy. It's proving things by reductio ad absurdum. here is a proof of modus tollens, which is not taken here as a basic rule. It's a rule which can be proved by using some more primitive rules, and mostly the proof is done by the reductio ad absurdum method. So let us read it. Here we have two assumptions. So the, say, premises or the first part of the rule we are willing to establish. And we want to establish even this formula as a conclusion, or yes, conclusion of that rule. Now, the reductio proof tells us that we must negate our desired formula. So the formula 3 is an assumption of the reductio proof. Then we use some simple logic to establish the formula 5. Yes, and the formula 5 contradicts the formula number 2. And because of this, we are allowed to establish the negation of the assumption per absurdum. This is pretty standard, yes? Now, let us think about the, say, philosophy of this. What's happening here? Is this inference from 1 to 6 is an inconsistent set of formulas. There are two straightforward contradictions there. And from an epistemological point of view, it means from contradiction you can derive this. Okay, I agree. It's a logical rule of called explosion, or the law of Duns Scotus. From contradiction you can obtain anything. So what's the goal of inferring something? It is to infer anything. This is a criticism from an epistemological or general epistemological point of view. So on one-dimensional approach, reductio ad absurdum is a very strange phenomenon which contradicts some basic idea of one-dimensional approach, that we go from that we infer something in order to support the conclusion. Now we support this conclusion by a contradiction. This is strange. So maybe you notice something, maybe you know that there is Fitch-style natural deduction. And in Fitch-style natural deduction, the formulas 3, 4, and 5 are set apart as a special part of a proof. So there are two sets of formulas in the set of formulas from 1 to 6. So Fitch noticed that there is something strange happening inside, but he didn't convert his view from one-dimensional thinking to the two-dimensional one in order to revise the whole approach. To sum up, one-dimensional approach is a simple and nice model of reasoning, but there are problems, and I have noticed only the problems number 1 and 3, that is, that we are establishing a conclusion in an unwarranted way, that reductio ad absurdum proofs are strange from a one-dimensional point of view. And what I didn't show you are two other problems. One is, say, philosophical or epistemological, that one-dimensional model of inference is setting aside a flow of inferential or logical strength. Only in reductio ad absurdum we feel that that there is some strength, logical strength involved, and it is because of the presence of the contradiction in the sequence. Okay, what is much more discussed in logical literature is so-called assumption discharge in the case of implication introduction rule, but I drop it from my slides. But there is, as I told you, there is a large literature on the topic. So, the worst part is behind us, that there is a nicer part, which is about two-dimensional conception, and there is something strange that it takes derivation as the inferential steps. Inference rules operates on whole derivations, and what is important from a philosophical point of view, each step is a logical truth. The first man who noticed that very clearly was Pavel Tichý, who found a predecessor in Frege. We will see some quotations both from Tichý and Frege, and there's a nice paper by my former doctoral student, our colleague I can say, Ivo Pezlar, which revised or revisits Tichý's conception, puts a lot of quotations, say from Jaškovský, together and documents how two-dimensional approach has been touched by several important logicians in the history of modern logic. So two-dimensional conception is not something created or something quite new created by Pavel Tichý. It is something what has occurred somehow in some form even in earlier literature. There is a quotation, but the quotation is not perfect because it doesn't satisfy my terminology. So I will read it. Using my terminology. So, according to two-dimensional view of inference, the inferential steps are not mere assumptions, but whole derivations, which are called entailments by Pavel Tichý. Now, a sound derivation is called by Tichý a valid entailment, and according to Tichý, you go from valid entailment to another valid entailment. Or if I change the terminology even more, you go from one logical truth to another logical truth. In Frege, there are several places which reminds you that he had the notion of two-dimensional inference in mind, but maybe he was not so explicit about the two-dimensional conception because there was no opposite literature, or not enough literature contradicting his views. So he only presented his ideas on some occasions, in some papers, even in papers not published. But anyway, you can feel that he had the two-dimensional conception in his mind. For instance, he says that if we take a sequence called inference, a sequence of thoughts, as one group of thoughts, each that thought must be true. So inference consists of true thoughts, because hypotheses or even false premises, this is the case of indirect proof, cannot be used as premises in inference, or assumption as I use the term. Let us use symbols to clearly see the difference between the two conceptions. The set of assumption is called gamma, and I use the arrow sign as something between, or not discriminating between, syntactical notion of consequence and semantical conception of consequence. So the arrow is the consequent or logical consequence sign. You can think of it even as an implication. I've got technical tools to convince you that it is a kind of implication, but only I prefer discussion for this, not the present moment. So you basically understand that we are in logic, and arrow means something forces us to put phi after the gamma. So given gamma, you must climb even phi, something of that style. This entity is often called sequent, where the first part is called antecedents, that is, each formula in gamma is called antecedents, and the last part of a sequent is called succedent. So the last formula is succedent. Now it is obvious that two-dimensional conception is a sequence of sequence, and each such sequence models a derivation, or it is a derivation, I can say. So these are symbols. Now I'm telling you a strange news for you. In introduction courses of logic, natural deduction or Hilbert-style deduction is used as the deduction systems. But if you look in work in computer science or even proof theory, sequent calculus is the primary derivation system used. And in computer science, many people use natural deduction in Gansen style, which is a natural deduction enriched by ideas of sequent calculus, mainly in using sequence. So natural deduction uses sequence as well. Thank you. Yes. So it is not difficult to translate familiar rules into rules understood as implementing the idea of two-dimensional inference. Most of this part of this work is already done, so this is not a problem. What it might be a problem a little bit is a translation of inference as understood but by a one-dimensional conception to the two-dimensional one. But I have observed that in fact the two-dimensional conception is hidden in this derivation supplemented by annotations. Because the first row tells us, take phi as an assumption. And in two-dimensional language, it means that basic axiom phi entails or forces to accept phi is used as the first step. So we can say that annotation tells us how to translate one-dimensional inference into two-dimensional inference, where the two-dimensional inference is a logical object. So in a sense, we go from meta-language to an object language. Okay, this is a theory. Let us go to a practical example. And this is a nice example published by former wife of Pavel Tichý posthumously by adopting his manuscript. And I'm using the example extended in order to convince you that two-dimensional conception is a good conception. And Tichý considers a problem how to convince Peter that some R is valid given P and Q. And there's another assumption, Peter has a standard rationality. Our problem is that Peter hesitates to accept R despite that P and Q do entail R. So from P and Q, it is correct to derive R, but we must convince Peter. So we must use inference, and we must use it in order to convince him that there is no other possibility than to accept R, given you accept P and Q. So this is a simple example. We will see it in the present moment. In order to convince him, he must repeat him that he believes P. P, yeah. He believes even Q. Note that I show here sequence of two-dimensional approach. And now there's a complicated part. We assume that, that R is not valid. So we assume that Brent is a good nurse, a negation of R. And here's a sequence that is strange. I don't believe it, because I know that P and Q gives us R. But nevertheless, this whole sequence is valid because P and Q and non-R gives us non-R. This is okay. Now, a complicated step is from the sequence 3 to sequence 4, but it is established by logic. Let us go back. We start with R, which is negated. So we drop this negation. We have a singular statement. And now here is a universal statement. And if we drop the universal quantifier and put little b instead of both occurrences of y, we get an implication and we have its first antecedent. So by modus ponens, we get the consequent of the implication, which is a negation of P. So there is a step from 3 to 4 that given non-R and Q, we have non-P. And now an important part in convincing Peter, look, here's a contradiction P and non-P. And from this, so the contradiction is based on your assumption P, Q, and non-R. And there is a rule called reductio ad absurdum rule, which tells us that we can go from 5 to 6. And 6 has, we have demonstrated the formula R as depending on the assumption P and Q. The reductio ad absurdum rule is a rule which is written here. There is a quite similar point for indirect proof. In the first part of this slide, I criticize the obvious explanation of indirect proof on one-dimensional approach. And I say that indirect proof is nothing but a rule which tells you that if you want to establish this sequence, you must establish this sequence first. So it is a direct proof. And this was already known to Frege, who tell us that there is no principal difference between direct and indirect proof. I skip this in order to provide a conclusion. The conclusion is obvious. Two-dimensional conception is better than the first dimensional one. Well, it's a little bit more complicated, but in fact, it's implemented in sequence calculus and natural detection, so in Gensen style. So the whole point of two-dimensional conception is already existing, and there are some pros of two-dimensional conception in the explanation, reductio ad absurdum, indirect proof, assumptions, and even the epistemological idea that in logic we go from one truth to another truth. So, conclusion has been already established, I hope. I would like to thank you. That's it, and I'm ready for your questions, answers, and criticism. Thank you very much.
So, Please ask your questions, and I will try to, even if it's a quite inconvenience, to force you to use the microphone because we need it for our record.
Andrius Kulikauskas, Vilnius Gediminas Technical University. Thank you for an educating presentation. But then it seems like it's a cultural decision that whether to use one-dimensional or two-dimensional. And I guess the convincing argument that you gave is many people have no understanding of proof by contradiction. So it's important to walk them through. And I think the two-dimensional lets you walk them through that. But on the other hand, culturally, you would like those people, once they get it the first time, to feel comfortable with proof by contradiction and to be talking about assumptions rather than truths. Because I don't think that you could really list a truth that's really a truth. They're all kind of assumptions anyway. So then it just seems like a band-aid, to say, well, for people who have difficulty, because why would you keep repeating the same type of argument for people? Wouldn't you prefer for them to learn how to do proof by contradiction?
Yes, I'm not completely sure that I've got an optimal answer to your question according to your criteria. Well, I'm teaching logic, and I must start with one-dimensional conception simply because it's simpler. And two-dimensional conception helps me to make a second-level teaching, so to speak. So I will show him this, telling, oh, that's it, and then I revise the original concept and telling, well, there is a problem, you can approach it differently, and the whole point of reductio ad absurdum or indirect proof becomes more natural. So it's in logic, it would be idle to start with lambda calculus, because it's the final theory, and say Gens and sequent calculus and lambda calculus together. Yeah, but it's too complicated. So we begin with propositional calculus, and people learn how to use ordinary logical connectives. They understand truth functions and so on. And then there's a complication called quantification. This is the second semester.
That helps. Thank you.
Yeah, thank you.
Thank you for interesting talk. I actually enjoyed that very much. Just to clarify on one point, when you speak about logical truths, do you mean kind of necessary and like analytic truths, or you just mean something true and that you can use? Just to clarify on that.
Yeah. Language is evolving, everybody knows that, and Quine reminds us that no truth is fixed for every possible world, so to speak. So language evolves. But in logic we usually use a language which is not evolving, so meanings are fixed, yes, and we infer something from the sentences given with some fixed meaning. So the logical truth is true in a, say, narrow sense, because the same sentence can obtain another meaning in evolution of language.
But you accept like scientific truths which are just empirical to your as logical truths. Could they function in two-dimensional logic?
Well, it is much more difficult question for me, because I'm not sure whether empirical laws such as E equals M times C and C square, thank you. Is it a logical truth? I don't believe so, because there is a meaning involved, but something tells me that there is some necessity. Maybe it's not a logical necessity, it's another necessity, but let us go back to our example, the natural language example. Each sequence here is a logical truth. We abstract from meanings of P, Q, and R. We only assume that these are different, but you cannot convince me that some of those sequence is not a logical truth.
Right, but
For instance,
It's
from
being a
Q,
logical truth.
it's okay to derive
oh, I see. Okay.
from
okay,
Q
okay,
to
yeah, I
derive
see.
Q.
I see. I see.
So what is important here is that this is a zone pattern,
Okay.
a zone derivation.
Okay. Okay. I see. Thank you. Yeah.
Thank you.
Are there any other questions?
So maybe another way to think of what you're saying is that you're just making explicit the formal nature of the truth that you want. You don't want to be speaking about assumptions that as if they were facts about the world, but you want to be able to point to the things, to statements like this that are as absolutely true as could possibly be, within the sense of your logical system, right? That there's nothing implicit, like you said, behind it. Everything is completely explicit. And that's the advantage of the two-dimensional inference, is that you're able to you're able to say this is explicit and you can see.
Yeah.
There's no confusion. Is that basically the...
Yes, basically. Perhaps on the first slide, I've told you that there's a sequence of sentences and something is hidden. And logicians and even ordinary people put those things hidden on the light. In ordinary discussion, it's background knowledge. Sometimes it's necessary. Or these are, evolve the meaning, and this is useful in putting dependent questions. So it is a reconstruction, and this reconstruction of reasoning is putting something on the light, and these things are on the left-hand side of that arrow sign. And there's a nice quotation which I didn't put on slides from Frege, that he said there, the whole point of this is that people needn't to keep those assumptions in mind. These are now written here.
So maybe then, though, that's the upside, but the downside then is this kind of critique that it maybe looks better than it really is. So because in all of the practical problem in applying logic is we are talking about a person like Socrates. Well, 2 seconds later, is he still Socrates? You see, that's a practical question. So by the time you get to so you say Socrates equals to Socrates, but which Socrates are you talking about, 2 seconds ago or now? You see, by formalizing it, you cover up all this real problem. So the other alternative is just to kind of it may be more honest, just to say, it isn't so formally, it can never be really so formally true. The formalism is actually, because you can never really have a real application of a system like what you're offering.
If I can repeat it in the following way, I would say that this is, we live in a wild of argumentation. Many things happen. And we are using, in fact, simple models to understand something. And here we try to understand some style of reasoning, and we abstract from some things which are not important for the whole point. So the goal of two-dimensional, there were several goals to explain, which were mentioned here. So epistemologic security, to explain assumptions in a reasonable way, and those strange practices according to one-dimensional conception.
Okay, so thank you for having a discussion.
Thank you very much. Thank you.